Hi everyone. Hi guys. Yes, you are able to hear me, right, guys? Do let me know on the group chat, like in the chat, so that you are able to hear me. Then we will start the class, like the session. We will start. Do let me know on the group chat, guys. Yes, able to hear you. Okay. Sure. Okay. Yes, sir. Fine. So in the previous in the previous session we learn about the static routing and we learn about different types of routing. So how many types of routing we have, guys? So in the previous session we learned, right? So how many types of routing do you have? Can anyone mention on the group chat that how many types of routing do we have? How many types of routing do we have, and what routing protocol we learn like yesterday? So yesterday there was a session, right? So on that session we learn about like okay, there are three different types of routing. So can anyone like list down the names? So that would be better. Yes, guys. So I'm seeing your chat group. Okay, so static, dynamic, fine, and default. Okay, so static, dynamic, and default. So fine. So we have static routing protocol, dynamic, as well as the default routing protocol. So in the previous session, we learned like we understand about how the static used to be work, right? So the static routing protocol. So what we need to do, how we need to configure in the static routing protocol, right? So likewise, in today's session, we are going to discuss about the dynamic routing protocols, right? So in the dynamic routing protocols, again we studied right in the previous slide itself, like in the yesterday's the yesterday's live session, we understand that we have a three different routing protocols: a static routing protocol, as well as the dynamic routing protocols, and the default routing protocol. So static we already covered that. Now, so we are going to be understand what is a dynamic routing protocol and in dynamic routing protocols, right? In dynamic routing protocols, that is again divided into like classified into IGP and EGP, interior gateway routing protocol, and the exterior gateway routing protocol, right? So that interior gateway routing protocol, we have the first protocol is like, so which protocol we have RIP, right? Routing information protocol. So let me share my screen so that uh, you can able to see my screen. Okay, so let me share my screen, guys. 1 second. Okay, screen share. So you guys are able to see my screen, right? Nice. Fine. Yes, guys. Okay, so you guys are able to see my screen. So in the previous session we discussed about, right. So we have three different types of routing: static and dynamic and default routing protocols. Right. These three we discussed, and we have a good solid understanding about these protocols as well. Right. We have a solid understanding about these protocols as well. Right. So today we are going to be discuss about the dynamic routing protocol. So in dynamic routing protocol, so the dynamic routing protocol is again divided into IGP, interior gateway routing protocol, as well as EGP, exterior gateway routing protocol. Right. So here, if you see, guys, okay, if you see here, like in IGP, so we are going to take this one the first time. So in IGP, you can see there is a first protocol is RIP. RIP stands for routing information protocol. Routing information protocol. So this we are going to be discussed today. Okay. So based on the RIP, so how the RIP is going to be work, that we are going to be discuss in a moment. So same, guys, again I'm going to take the same lab, so you can see my lab as well. So here we are going to, once we covered about our theoretical point, right, so then we are going to discuss about the lab part as well. So here we have a different routers, right? We have a different routers. Based on that we are going to be login, right? And we are going to be do the lab here. We are going to do the lab as well, right? Right, so fine, lab is fine. So let me do one thing. Lab is fine. So I take the slide here. The new one I need to take, right? So today we are going to discuss about the dynamic routing protocol RIP, right? RIP stands for routing information protocol. So what we are going to discuss? We are going to discuss about RIP. RIP stands for routing information protocol. Guys, this dynamic routing information protocol earlier, guys. So I'll ask you everyone now. Okay, so we learn about the static, right? Static routing protocol. So when we are going to configure a static routing protocol between the like routers, like between the devices, so we need to, as a network engineer, you guys, like the network administrator or the network engineer, has to be configured manually, right? So the network administrator or the network engineer has to configure manually the neighborship, right? So to configure the static routes, the network engineer, right, the network administrator or the network engineer should have a, right, should have a should know the destination network information. So without knowing the destination information, so he's not able to configure the, is not able to, like the network engineer is not able to configure the what static routing protocol, right? So today we are going to discuss dynamic routing protocol. See, I'll tell you what is the exact difference between the dynamic routing protocol and the static routing protocol. So if you see here in the lab, let me take the slide of this. Okay, so if you take this slide, right, so if you want to configure a static routing, guys, static routing protocol here. So first, in between these two routers, so consider this is our R1 router and this is our R2 router. So if this LAN users, like whoever sitting here, 192.168.1.0/24 LAN users, if they want to access to this particular LAN, like 2.0/24 LAN, so then what we need to do, we need to configure any routing protocol here. So the previous session we done about the static routing. So you need to define a route from this router towards to this LAN, right? And when you are going, this is your forward route. Then again you need to decide a route from this LAN, right? So from here to reach to this particular LAN. So manually we are going to be configured here. See, in the router one we are going to, like we are going to say that, like to reach a 2.0/24 network, the next hop will become this guy. So reach to here 1.2, right? So this is going to send your data packet to this your LAN network. So that's what we discussed. But in dynamic routing protocol, you need not to be, like you need not to be know about your destination network. See, consider this is your source network, right? And this is your destination network. So if you are in a source router, so here you are there and you are configuring the RIP protocol, routing information protocol, RIP, routing information protocol. And so if you want to reach from this particular LAN, right, so 1.0/24 to 3.0/24. So if you are trying to build a neighborship between the router 1, see, between from this router 1 to router 2, you need not to know about what is the destination network. So that is what the beauty of the, that is what the beauty of the static dynamic routing protocols. You just need to introduce your directly connected neighbor information, sorry, your directly connected interfaces information. See here how many interfaces I have. I have three physical interfaces. This is fast ethernet 0/0. Here I have a fast ethernet 2/0. Here I have a fast ethernet 1/0. So every physical interface will have an IP address. So here we have an IP address, right? Likewise, here also we have an IP address and here also we have an IP address. I just need to configure, like when I'm going to configure in this router, right? I just need to be configured. I just need to be introduced, right, in the routing protocol, just the directly connected network information. So this network information and this network information and this network information. Now, what is the trick here? See, if you see here, we have a dot one and dot two. Okay, so here we have a dot one and dot two. Here also, so guys, this is not a /32, it's a /30. Okay, so yesterday also I modified that, right? So this is /30. Everywhere I used to take /30 because we used to get like around two valid IP addresses. So that two valid IP addresses, we are going to assign one IP for this side and the other IP for this router, right? So if it is, what is the network ID? So whenever you see 0, right, so this is your network ID, right? So this is your network ID, this is your network ID. So from this network ID, whatever the valid IP addresses we used to get, that IP address we are going to configure. Here is 1 and here is 1. So generally in this slash 30, right, slash 30 pool, you used to get only two valid IP addresses. That I am going to assign one IP address on this interface in router 1 and the other IP address in router 3. Likewise here also. So here we have a 172.17.1.0/30. So this IP address, like here also we used to get two valid IP addresses. So one IP address here I'm going to assign on this physical interface, and the second IP I'm going to assign here. Likewise, here we have a 172.18.1.0/30 subnet. So here also we used to get two different valid IP addresses. So we are going to assign followed by the interfaces. So for the router 1's LAN, we are going to take 192.168.1.0, and for the router 2's LAN, the LAN network, we are going to take 192.168.2.0. Likewise, for router 3's LAN, we are going to take 192.168.3.0. So this is what our topology. Earlier we used to introduce, when you are going to configure the static route on router 1. So how you are going to be configured in router 1, you are in a global configuration mode, right? So here you used to type IP space route, right? IP space route. So what is the destination network? This is your source network, right? So in router 1 you are there. So this is our destination network, right? So in this network, so what is the LAN destination network ID? So here you used to mention like 192.168.1.0, and the destination subnet mask is 255.255.255.0. Now either you can use this exit interface or else the next hop IP address. Okay, both is fine. Anything is fine. So that's how you used to configure. So if you want to reach from router 1's LAN to router 3's LAN, right? Since from here to here. So what you require to configure a static route, you require a destination network information. If you don't have a destination network information, right, the destination network ID and the subnet mask information, then you will not able to configure a static route. But this is not the case in the dynamic routing protocol. So that's what I'm trying to explain you. In the dynamic routing protocol, you don't want to be bothered about the what is the destination network ID. You just need to introduce your directly connected the interfaces IP addresses network information only in this particular router 1. That we will do in a lab. So first we will understand how RIP used to be work, right? So now I think so we have enough numbers, like around we have 15 guys, or like 18 guys we have. So it's well and good. Okay, so we can do that, right? Now we can discuss about the routing protocol. RIP stands for routing information protocol, right? So today we are going to learn about the RIP, routing information protocol. So first we will discuss about the functionalities. What is the functionalities of the, right? The functionalities of the, okay, the functionality of the RIP, routing information protocol. So guys, RIP stands for, what is RIP? RIP stands for routing information protocol. RIP stands for routing information protocol. So in dynamic routing protocol, again I'm going to tell you, right? In dynamic routing protocol, we have a IGP and EGP. So today we are going to discuss about in the IGP's protocol, interior gateway routing protocol. In IGP, we have a RIP, routing information protocol. We have a EIGRP, right, enhanced interior gateway routing protocol, as well as we have a OSPF, open shortest path first, and we have a IS intermittent system. So today we are going to cover deep dive with the RIP. So RIP stands for routing information protocol, right? So these protocols, guys, okay, again the take away point from here. So every routing protocol used to be work in a like a protocol, right? Every dynamic routing protocol used to have an algorithm, and it used to be use a protocol, right? So that we are going to be discussed. So in RIP, if you see here, so RIP stands for a routing information protocol. It's a distance vector routing protocol. So RIP is going to be considered, like RIP is going to be, if you configure the RIP, routing information protocol, in the routers, so it is going to be run based on the distance vector routing protocol, which means so how much distance is there between source to destination. So that is going to be calculated based on the distance vector routing protocol, and it is an open standard protocol. So what is open standard and what is Cisco proprietary? Can anyone like Cisco proprietary? So we all know this. What is the term? If you see Cisco's proprietary means, what is the meaning of Cisco's proprietary, guys? I'm just watching the chat. Okay, so just let me know on the Cisco, like what is the Cisco proprietary. So proprietary means what? Example, if you can take Cisco's proprietary. Yes, can anyone? Cisco's proprietary and the open standard. What is the difference between Cisco's proprietary and the open standard? This question you will get in an interview as well, guys. So that's the reason uh, I'm just looking the answer. Like I'm just trying to get the answer from you guys. Yes, Kiran Das, it's owned by Cisco, right? Fine, like you're good. So Cisco's proprietary means we have few protocols, guys. So in our CCNA, so when you are studying, right, the CCNA. In CCNA, we have few protocols. Like few protocols are the proprietary protocols, which means the Cisco's proprietary protocols. That protocols are going to be work only in a Cisco's routers, or switches, or firewalls. Like see, the Cisco's protocol is going to be work only on the Cisco's devices, not in the other devices. So open standard means so we have a multiple OEMs, right? Original equipment manufacturer. So we have a multiple OEMs. So multiple OEMs, right? So if it is the open standard, right? The protocol is an open standard protocol. You can run in any protocol. Consider this is your router one. This guy is a Cisco's router, right? This is your Cisco's router, which is connected with other router like router 2. It's a non-Cisco router. It's a non-Cisco router. Now the both the routers are trying to establish a connectivity or form a neighborship with the help of RIP protocol, routing information protocol. So you can configure the RIP between both the devices, because this RIP protocol, routing information protocol, is an open standard. So it is going to be work on the Cisco's devices as well as non-Cisco's devices. In the next session, we are going to study about the EIGRP, Enhanced Interior Gateway Routing Protocol. It used to be work on the Advanced Distance Vector Routing Protocol. Okay, it's a Cisco's proprietary, guys. Just the point was came, so that's why I'm going to discuss here. It's a Cisco's proprietary. It is all. It is going to be work only on the Cisco's devices. Okay, that is what the difference between what is the Cisco's proprietary and what is the open standard. So open standard is better, so that you can run in any networking device. So as we said, right, so every routing protocol will have a algorithm. So RIP algorithm is Bellman-Ford algorithm. So actually RIP protocol, routing information protocol, was invented by the Bellman only. So he has given his name to this protocol, right? So the algorithm name has given as a Bellman. Okay, so Bellman has invented this RIP, routing information protocol. So the algorithm name itself he has given as a Bellman-Ford algorithm. And the next point is classful routing protocol. Okay, what is classful routing protocol? See, the classful routing in routing protocols we have, right. It's a classful routing protocol and classless routing protocol. Classless routing protocol, right? Classful routing protocol and the classless routing protocol. So, what is the difference between here, guys? Okay, so in RIP we have a two different versions. So this you need to be note down. Okay, version 1 and version 2. So in RIP we have a two different version, like RIP, routing information protocol version 1, and RIP version 2. So version 1 is the classful routing protocol. So okay, version 1 is the classful routing protocol. So that's the reason. Classful means always you need to be used like the classful IP addresses, right? So classful, there is a slight difference between the classful and classless. So what is classful and what is classless, that we will take care. Okay, but as of now you can remember that, okay, RIP, routing information protocol, is going to be support for classful only, right? And the RIP version 2, that's why, okay, it was invented like upgraded. RIP was upgraded from version 1 to version 2, and version 2 is going to be support for classless as well. So RIP version 2 is also going to be support for classless. So in RIP, routing information protocol, we have a two different version, RIP version 1 and RIP version 2. So RIP version 1 is a classful routing protocol, right? So in classful routing protocol, guys, okay, I told you, right, to form the neighborship in the dynamic routing protocol, we used to have a like the messages has to be exchanged, right? The messages has to be exchanged between the routers. Consider this is your router one, right? It is going to be connected with router two. So here you will have a IP address 172.16.1.1/30, right? So likewise here also you have a IP address, right? Here also you have a IP address 172.16.1.2/30, right? It's a slash 30 subnet, guys. So we will get two valid IP addresses. So in dynamic routing protocol, to form the neighborship, it used to exchange hello messages between the routers, right? So the hello messages are going to be exchanged with the help of multicast address. Multicast address. With the help of multicast address. Now we have a IP address concept, right? IP addressing. In IP addressing, we have a IPv4 and IPv6 version. So we have a IPv4 version, Internet Protocol version 4, as well as we have a Internet Protocol version 6. So this IPv4 was again classified into like five classes, right? Class A, Class B, Class C. That we know that like since from Class A to Class B and Class C, these ranges we are going to be used for LAN and WAN purpose, so that we can assign the IP addresses from LAN to WAN. But there is another class, right? Class D. Class D is when I explain you the IP addressing concept. Even though I uploaded the video also in the YouTube, you can go through with that, right? So Class D is reserved for multicasting. Class D is reserved for multicasting. That time I was explaining you Class D is reserved for the multicasting, and the range is it is going to be start from 224 to 239. So the whole range is reserved for the Class D range is reserved for the multicasting, right? So it was reserved for multicasting. See, now you are going to understand where exactly that multicasting IP addresses are going to be useful. See, when if you connect both the routers and you configured RIP here, routing information protocol, here also routing information protocol, then the routers are going to be exchange the hello messages between each other, right? When it is going to exchange the hello messages, that hello messages are going to be exchanged with the help of multicast address. So every routing protocol, whenever they are going to exchange the messages, right, they used to have a multicast address. They used to have a multicast address. See here, updates are periodically broadcast using the IP address 255.255.255.255. I told you in when you are going to when we discussed in the previous sessions, right? So in our previous session, we discussed the IP address is going to be start from 0.0.0.0, and it is going to be end for 255.255.255.255, right? So this is what the range start and end range of the IP addresses. You can see here. Here you are going to see 255.255.255.255. So it is what, so that's why he has mentioned as a broadcast, right? See, I told you, right, whenever you see 0 in the IP address, you can consider that is your a network ID, that is your network ID. And whenever you see dot 255 in the last octet, whenever you see the 255 in the last octet, that is going to be considered as a broadcast ID, broadcast ID, right? So here also you are seeing the same things here, broadcast, right? So updates are periodically broadcasted using the IP address 255.255.255.255 or multicast 224.0.0.9. So as we discussed, guys, RIP, routing information protocol. In routing information protocol, we have two different versions. One is RIP version 1, routing information protocol version 1, and we have the another version which is RIP version 2, routing information protocol version 2, right? So version 1 is going to be support for class full networks only, class full network, and RIP version 2 is going to be support for classless routing protocols, right? Classless routing protocols, and RIP version 1 is going to be support for classful routing protocol. So if you are going to be configured between the routers from R1 to R2, so here you will have a LAN, right? So this is your LAN, Consider this is also again your LAN, guys. Okay, so if you are going to configure RIP version 1 in this router and again in this router RIP version 1, right? This both routers are start exchanging the hello messages with the help of broadcast. The broadcast address is 255.255.255.255 for RIP version 1. So this clarity you should have. And right, say that RIP version 1, in RIP again we have two different versions, RIP version 1 as well as RIP version 2. RIP version 1 is going to be support for classful routing protocols, and RIP version 2 is going to be support for classless routing protocols. So if you are going to use RIP version 1, then the broadcast address is 255.255.255.255. 255 is all the four octets, right? If you are going to use RIP version 1 between the routers, see now what will happen, right? So if you are going to use RIP version 1 in these routers, RIP version 2, then this routers, router 1 and router 2, are going to exchange the hello messages with the help of multicast address. If you are using RIP version 1, then they are going to exchange the messages, hello messages, with the help of broadcast address. Like in the same topology, if you are going to like use the RIP version 2, right? RIP version 2 in the both the routers, then both the routers are going to exchange the hello messages with the help of multicast address, and that multicast address is 224.0.0.9. So this is again very important point. See, in interview they are going to ask you, tell me about RIP. They'll just ask you the tell me about the functionalities of the RIP. Then you need to be explore a more, right? So compared to the others, you need to be explore a more. So that's why you need to be remember this. RIP is what? RIP stands for RIP stands for Routing Information Protocol. RIP stands for Routing Information Protocol, and it's a distance vector routing protocol. Okay, so it is an open standard. So RIP is an open standard routing protocol where we can use in any routers like Cisco's routers and the non-Cisco's routers as well, right? Cisco's and non-Cisco's routers as well. So RIP routing information protocol is going to be used for the Bellman-Ford algorithm. And so in RIP, we have a two different version 1 and version 2. When you are going to use the version 1, it is going to be act as a classful routing protocol. And when it is a classful routing protocol, to exchange the messages, it is going to be used, right, broadcast IP address, which means all 255 and all the four portions, right? So this is what it is. If you are going to configure the RIP version 2, so earlier guys we have a RIP version 1, then the protocol was upgraded from version 1 to version 2. So version 2 is better compared to version 1 because version 1 is a classful routing protocol, right? And version 2 is a classless routing protocol, and we are going to be used here the multicast address is 224.0.0.9. See, this is how the routers are going to be exchange the messages between the this is how the routers are going to be exchange the messages between the Cisco devices we need to use for protocol to use the protocols within the Cisco device. Okay, it's owned by Cisco. Okay, Sai Kumar, fine. Sai Kumar, open standard for any devices. Yes, open standard means you can configure on any devices. Should Ismail, okay. Hi, hi Ismail. Okay, and good afternoon, Sadiq. Good morning. Good afternoon, Lukman sir. Yeah, yes, Sheikh Ismail. Hello. Nice. Okay, so this is what the functionalities, guys, for the RIPs, and we will discuss about the remaining functionalities, right? Now, see, updates are sent via the UDP. Updates are sent via the UDP. So, in OSI model, Open System Interconnection, we have a 7 layers. We have how many layers, guys? We have a 7 layers. In the 7 layers, layer 4 is what? It's a transport layer, right? Layer 4 is transport layer. In transport layer, we have the service identification. Service identification means what? It's whether the service is based on the TCP or UDP, right? So here we have a TCP and UDP, right? In transport layer, TCP and UDP. TCP stands for Transmission Control Protocol, and UDP stands for User Datagram Protocol, right? TCP stands for Transmission Control Protocol, and UDP stands for User Datagram Protocol. So when you are going to use the TCP, it is going to have a three-way handshake. But if you are going to use a UDP, there is no three-way handshake and no acknowledgement as well. So the point is what? So in RIP, we have a points updates are sent via the UDP port number 520. So in interview, guys, you need to remember this all points. Whatever we discussed right till now, those all points are very important because in interview they are going to ask you each and every point. See, between the routers, when it is exchanging the messages, right? So how we are going to identify from which protocol we got the update based on the port number also. So we can see the port number on the updates, right? The IP header packet. And generally, guys, in the headers we have like Ethernet header, Ethernet header, or someone used to call as a layer 2 header. That is also fine, right? Ethernet header. If the packets hit to the switch used to send the packet along with the data, it is going to add the Ethernet header. Then if that packet used to reach on the router, right? Router used to add the IP header, IP header or L3 header, you can say. Then in transport layer, we will have a TCP IP header, guys. TCP IP header. So these headers are very important for to clear your interview. So in every interview, you will see there at least you will get minimum 2 3 questions from this here, like what is the difference between TCP and UDP, right? And how the TCP difference between OSI layer and the TCP IP layers, right? And how many fields we have, how many fields we have in a TCP IP layer, right? And what is our TCP flags? They are going to ask you list down all the TCP flags. These all are important things. Like in TCP flag, we have SYN, right? We have a acknowledgement, we have a push flag, we have a urgent flag, and we have a reset flag, we have a fin flag. So almost all we have 6 flags. So these all are important, guys. See, having a knowledge like full-fledged knowledge, then only will easily crack the interview. So we'll discuss about that headers also. But as of now, so TCP UDP that is going to be segregated. The service identification is going to be happen in service identification is going to be happen in the transport layer, right? In the transport layer, TCP UDP is going to be identified, and we have the port numbers as well. What is the port number for TCP and what is the port number for UDP? So likewise here, guys, UDP RIP is going to be used. The UDPs to UDP port number 520 to send the updates, and complete routing table sent as a update. Complete routing table is going to be sent as an update. So this point you need to be understand. So before we understand, we will draw a topology. See here we have a router, so which is connected towards a router 2, right? So there is a LAN, right? So here we have a LAN. So in this LAN, here also we have a LAN, right? So in this LAN, we are going to be used like the network is 192.168.1.0/24 network. So in this LAN, right, we are going to be used like 192.168.2.0/24. So we have two different LANs and two different IP addresses. So generally here you are going to assign 1.1 as a gateway. Here you are going to assign 2.1 as a gateway. And here I am going to take the address. The network ID is 172.16.1.0/30. So that I used to get dot 1 here and dot 2 here. So this is what our topology. So first we need to do the basic configuration that everyone knows, that basic configuration, which means the host name and the IP address assignment of the all the devices respect to the interfaces, this physical interfaces, right? So here we have to assign the IP addresses on this particular interfaces. So once you've done right, then you are going to start configuring the RIP protocol. Then you are going to configure the RIP routing information protocol version 2. Consider here, and here also you are going to configure routing information protocol version 2. So once you once you done your configuration, right? So this router, right, used to send the hello message to router 2, and router 2 will also send the hello messages to router 1. So to form the neighborship. So hello messages are going to be sent with the help of a multicast address, and the multicast address is RIP is going to be is 224.0.0.9. So when updates are going to send, right, the hello messages are different, and the updates, the routing updates. What is routing updates means? So here how many networks we have in this router 1? So here we have one network like 192.168.1.0 network, and in the WAN side we have this network, right? So this is also going to be configured in the router R1. So here you are going to consider 172.16.1.0. So this two is your routing information, routing updates that will reside in R1. Likewise, here you will have a 192.168.2.0 and this LAN again WAN network 172.16.1.0, and this network information is going to be reside on this interface. Now, so once they form the neighborship, guys, once they become a friends, these two routers become a friends, right? So how they are going to become a friends? First, they are going to exchange the messages, the hello messages with each other with the help of multicast address, and the both the routers are going to become a friends, which means in a general language we used to tell as a both the routers are become a friend. So, but in a technical terms, like in the networking technical terms, we used to tell as a both the routers are form the neighborship. So once they both form the neighborships, right? So router one, right? Router one used to exchange their network information. Okay, this network information is to go give to the router two. Likewise, router two is giving his own network information to router one. So router 1 and router 2 both are going to exchange the routing information, right? Routing information or routing table. This is your routing table, guys. Okay, we'll say as a routing table, and this is also your routing table, right? So once they exchange, so what will happen? See, this routing table R2 is going to be exchanged with R1, right? So once you R1 get that routing table, right, that is going to be installed in R1's routing table. How it is going to be installed? So it is going to be maintained 192.168.2.0 and 172.16.1.0. These networks I have learned from RIP. So whenever it learned from RIP, it used to show as a R. Okay. So this information now installed in routers one routing table. Likewise, so this router, right? So again, R1 will also extend, right? R1 will also extend his routing table to R2, right? And R2 is going to be register that routes, install that routes, which routes this R1's routes in R2's routing table, right? R2's routing table. So it is going to be mentioned like this: 192.168.1.0 and 172.16.1.0. So these routes are going to be installed in router 2's routing table. So it before it is going to mention as a R1. Now you will see. So if there is a LAN user here, if he wants to go the 2.0's LAN, so the packet used to go to the R1. So R1 used to be check his routing table. In his routing table, he has the route like to reach 2.0 via RIP. So it is going to be send that packet the information to the router 2, and the router 2 is going to be sent to router 1. So that's how the communication used to be work. Even though if here there is a LAN user in R2s, right? So that R2 2.0 user wants to try to reach from R1's LAN. So the packet used to go to the router, and router always verify the routing table. In router's routing table, we have the 1.0 network, right? So router used to send the data to 1.0. So that's how in practical scenario the communication, the networking communication used to be exchanged, that we will understand. So but the point, what was the point we discussed? The points are complete routing table sent as a update, right? Complete routing table sent as a update, which means so there is a routing table, right? So this is the routing table, this is a routing table of R1, that complete routing table which is going to be sent to router 2. Likewise, R2 will also send his complete routing table information to R1. Sometime it is an advantage and sometime it is a disadvantage, that we are going to know when if you upcoming in the upcoming series as well, right? So each update can be contain a maximum of 25 routes. Each update can be contain maximum of 25 routes. So we know that to exchange the routes, right, to exchange the updates, so router 1 used to send the update to router 2, right, and as well as router 2 used to send the update to router 1. When it is exchanging the update, it is going to be use UDP 520 port number, and it is going to be exchange the complete routing table. So this complete routing table will contain only 25 routes. Will contain only 25 routes. If when router 1 is going to send the routing table information as a update, using the port number UDP 520, using the port number UDP 520. If guys, if the update, if the routing table is having a more than 25 routes, more than 25 routes, then that update, the first update used to be contain only the 25 routes only. More than 25 routes, the router 1 in RIP, there is a again drawback, guys. There is again drawback, because generally you will see in the production networks, in the live infrastructure, right, in the production network, in the live infrastructure, you will have a multiple routing information. So here we are going to use only one LAN, but see there is a switch, right? So in this switch you will have a minimum like 50 VLANs information, right? So that all the 50 VLANs information that you are going to be like injected the routes in your routing protocol. So in production it would be difficult. So that's why we have a RIP, routing information protocol. Then the advance to this is we have a EIGRP, enhanced interior gateway routing protocol. RIP used to work on the distance vector routing protocol, and the advanced protocol EIGRP is going to be work in advanced distance vector routing protocol. Better we have an understanding of RIP. If you have a good understanding of RIP version 1 and version 2, then you can easily correlate the same thing with EIGRP as well as OSPF. So that's why I'm trying to explain you in detail, deep dive, because I can study the point and I can read and I can explain, but that's not the thing. So we have to be like have a in detail knowledge based on this protocol RIP. Based on this RIP, routing information protocol, we can correlate to the other routing protocols like EIGRP and the OSPF and the ISIS. All are same, but slight difference. The differences is only the uh, routing protocols, right? So which protocol it is going to be used, and the algorithms and the multicast address, and based on the timers sometime. Like I'll tell you what was the differences in each and every routing protocol. So you need to remember this. Each update can contain maximum up to 25 routes. If the update is more than 25 routes, then it is going to be, it's not going to send from router 1 to router 2. So AD stands for administrative distance. The other point is AD stands for administrative distance. So we studied, right, what is the AD value of static routing protocol, guys? I'm watching your chat and just let me know what is a static routing protocol AD value. Protocol AD value. Tirandas, cool man, very fast. What other guys? So you guys will you didn't join the yesterday's class and you don't want to be like you don't want to share your answer in group chat. Do some familiarity, guys. Okay. So the static route AD value is 1, right? The static route AD value is 1. So likewise, so the AD stands for administrative distance, right? AD stands for administrative distance, and whichever the value is less, whichever the routing protocol's AD value is less, that routing protocol is going to be preferred to inject this that routing protocol routes in the routing table, right? So whichever the routing protocol, guys, you are able to see my right? See me right? I thought I haven't seen. Guys, you are there, right? You are there. Can anyone let me know? So is there any issues? Because no problem. Everyone is good. So you are able to see my chat, right? Okay, chalo. So AD stands for administrative distance, right? And the AD range is going to be start from 0 to 255. This is the range of the AD values. Range is 0 to 255, and the static routing AD value is 1, guys. The static routing AD value is 1. So likewise, so every dynamic routing protocol will have a AD value. So static routing protocol is 1. If you go RIP, routing information protocol, AD value is 120, right? So likewise, we have a EIGRP, Enhanced Interior Gateway Routing Protocol. AD value is 90 for internal and the external routes 170. We have a OSPF, Open Shortest Path First. That routing protocol's AD value is 110. And even though we have a BGP, Border Gateway Routing Protocol, right? That BGP, Border Gateway Routing Protocol's AD value is, in BGP we have a IBGP and eBGP. So the AD values will be 220. So this is the AD value. So as we discussed, right, the AD value range is going to be fall between the 0 to 255 only. 0 to 255. So if you see here, the static routing AD value is 1 and the BGP's AD value is 255. So all the values are within a ranges only, right? So this you need to be remember as a fresher. So everyone is going to be evaluate, or they are going to ask you, right? So in interview they are going to ask you what is the AD value, right? So and if I configured in a routing, like I have a router, so in this router if I configured static routing protocol as well as like any dynamic routing protocol, any you can take any dynamic routing protocols. So which protocols are, like if I configure two protocols in the same router, so which protocols routes are going to be installed in the routing table. So that's how they are going to ask the cross question. So I just want to what AD actually means. Okay, how it is going to be calculated. So it is not going to be calculate Pallavi. Okay, it's not going to be calculate, and this is a standard AD administrative distance values. So based on these values, the protocols are going to be installed the routes in his routing table. So that's what I told you, right? So if you have a router in this router, if you configure static route as well as dynamic routing protocol, consider RIP, routing information protocol. So this router is going to install the routes on his routing table based on the AD value. Okay, so whichever the less value, that is going to be preferred. So guys, the old guys and the new guys, I just want to ask you. See here, I configured the static route and the dynamic routing protocol, RIP. Okay, routing information protocol. So which routes are going to be installed in the routing table? So either static routes or the RIP, routing information protocols route. Which routes? I'm just watching your chat group, guys. Just let me know which routes are going to be installed. Which routes are going to be installed in the router's routing table? Which routing protocol will come into the action? Obviously whichever the AD value is having a less, right? So B, okay, whichever the AD value is having a less AD value, so that protocol's routes are going to be installed in the routing table. So this is the total range of the AD value administrative distance, and static routing protocol will have a AD value 1. Okay, static, yes, Prasanna, static. So other guys also be active, boy. Okay, be active. So don't be just join and listen and without getting any takeaway points, without getting a content. Okay, what you are going to do. So be familiar. If you have any doubts, just let me know. No problem. I'll take care over the chat. But the thing is, be interactive. Don't sit simply. So as we discussed, the total range is 0 to 255, and this is what the each and every protocol. Based on that protocol, we have the AD values. RIP's AD value is 120, and the EIGRP's AD value is 90 for internal routes and 170 for the external routes, and the OSPF AD value is 110, and the BGP's AD value is 220. So this is what the AD values think. So likewise for RIP, we have the AD value administrative distance is 120, and metric is the hop count. Metric is hop count means so how many routes. See to for the verification whether, consider here we have a LAN, okay, switch, right? So again questions, guys, for everyone. Okay, I need answer from everyone. Don't sit and just watch the video. Do try to do the reply. See here I have a public IP address. This is my WAN, and this is my LAN. Now consider here I have a 8.8.8.8 Google server over the internet, right? Now my user from here, if he try to, okay, now he need to check the verification. He need to check the verification towards the google.com. He need to check the verification. So which command we can use? So if I want to check the connectivity from this laptop, whether it is a reach, like do you have internet or not? So which command do you have to use? Right? Which commands do we have to use? Ping. Okay. So if we use ping, so we will get to know the, yeah, we can use ping here. Ping space 8.8.8.8. So we will get to know whether the reachability is there or not. So now I need to know like from where exactly the packet is going to be traveled. So hop by hop, hop by hop. So for that, which protocol, which command we have to use? Nisar, Nisar, Nisar. स्वात ಆಯ್ತು ಫುಲ್ ಹೊರಗಡೆ ಬಂದಿದೆ. Yes guys, okay, Kiran das trace set, very good. So if you if you are running from Windows machine, then the command is trace set, right? Trace set space 8.8.8.8. So if you type this command, what output you will get? If you use this command trace set space 8.8.8, what output you are going to be get? So I'm trying to explore the answer from you guys, okay? So that Pallavi, where are you? Rishita, where are you? What you guys are doing? You know, right? What is the answer? You know, but you are not able to chat. Why you are getting any money? Like you are wasting any money when you are typing some answers in the group chat. See, by doing the ping, it is going to be checked like the connectivity, right? So if you use the trace route command, trace that command. So what is going to be happen? Yes, Kiran Das. Sai, where are you? Muzammil, where are you? See, you guys just joined and roaming outside, then no one is going to help you in your career, bro. Okay, so do be try to listen, try to learn the new things. See, everything is important. So mm, whenever you are like, see, whenever you are join any live or the classes or anything, right? So everything is important to be join with the class and try to learn. Okay, so if you are trying to hit the command like tracer 8.8.8, it is going to be show you hop by hop information, hop by hop information. So hop by hop information, by which you can say that if you are getting a huge latency, then you will get to know on which hop it is really we are getting the latency, that you are going to know by this command. If it is a Windows machine, right? If it is a Windows operating system or the Windows laptop, then you can use a tracer command. If you want to verify the hop by hop information from a router, then we are going to use a trace route command, guys. Trace route, okay. So in Windows it is going to be used as a traceset, okay. In Windows it is going to be used as a traceset, and in the Linux operating system we are going to use traceset trace route dot 8.8.8.8. If you use this command, it is going to show you, okay, it is going to show you hop by hop information. It is going to show you hop by hop information, that okay, from how many hops it was cross. So to reach from here, so first the packet, when you try to trace from here, right, first it used to go to the where here, like the default gateway. Then it used to go to the internet, the provider IP address. Then over the internet it used to go to the multiple hops. Then it finally reached to the 8.8.8, right? So that hop count information, this is my first hop and this is my second hop, third hop, fourth hop, and fifth hop. I used to reach to fifth hop. We check the packet stop now. Okay, cool. Okay, so the trace route command is going to help you to identify the hops. The same thing we have here. See, metric is a hop count. Metric is a hop count. So RIP's metric is a hop count. So RIP is going to be work based on the hop counts, right? And the maximum hop count support is 15 routers only. The maximum hop count, it is going to be support 15 routers. So since from router 1, if you have like this router 1, right, and you will, it is going to be connected to router 2 and router 3, right? So like this, I'll mention here router 15 and router 16, and there is a destination. So here we have a source address, and here I have a destination address, right? So anything you can consider. Here I have some source addresses, and here we have a destination address. Now my source address, or else you can consider my LAN user wants to reach to this particular destination address, right? So if you want to reach, right, the packets are going to be translated like this. The packet is going to reach R2, then R3, then R4 till R15. Okay, so till here the RIP is going to be support only for the account is 15, right? So once it is reached 15th router, it is going to drop. It is going to drop. because it is the RIP is going to be support the maximum hub count size is till 15 only, which means 0 to 15. If you count 0 to 15, like 16 routers, so the RIP's packet is going to be travel maximum 16 routers. So more than 16 routers, it is not going to be travel. If you are seeing right more than 16, if you see more than 16 routes, okay, if your destination is beyond 16 routers or the 17 routers, then RIP is going to drop that packet. Okay, so this is again a limitation in the RIP, routing information protocol. This is again a limitation in the routing information protocol. This you have to be remember, guys. In interview, it is very important. And load balancing on 4 equal paths by default and maximum 16 paths. So in RIP, we can do the load balancing. We can do the load balancing by default 4 paths. By default 4 paths. So by default, by using the 4 paths to reach a same destination. If you have a 4 paths, right, to reach a same destination. If you have a 4 paths, that is going to be do like this. Like consider example router one. Here we have a router two. So there is one path directly connected, and even though you have like this. See, if you have like this, right? So once the data used to hit to here in this router, that router is capable to do the perform the load balancing. By default, it is going to be support four equal cost load balancing and the maximum up to 16 paths load balancing. So this router is going to exchange the information. It is going to be use all the interfaces because all the routers are going to be connected with this particular destination, and here we have a source and this source to this destination. If you want to send the data, so it can be do the load balancing, that to equal cost load balancing. Unequal cost load balancing is not going to go perform in RIP, routing information protocol. RIP, routing information protocol, is going to be performed only the equal cost load balancing. So if you have a four different route to reach to the same destination, then the RIP protocol is going to be okay. Then the RIP protocol is going to be perform the load balancing. RIP will also known as a routing by rumor. Routing by rumor. We'll let you know why we are going to call as a routing by rumor. Just remember this, okay? So when we configure right, then we will get to know why we are going to be or why we are going to tell as a routing by rumor. So this is what the functionalities of the RIP, guys. This is what the functionalities of the RIP. So if you have any like a doubt here, just let me know. I'll try to explain you again, okay? But this is what the functionalities of the RIP. RIP stands for Routing Information Protocol, right? It uses the distance vector routing protocol, which means it used to be work based on the distance, and RIP is the open standard protocol, which means you can configure in Cisco's router as well as non-Cisco's router like Nokia, Juniper, Dell, right? So HP, Huawei, any routers you can configure. And RIP uses the algorithm is Bellman-Ford algorithm. He is the actually inventor of the this RIP protocol, and he has given his own name to this RIP. RIP uses the Bellman-Ford algorithm, and in RIP we have a two different versions. In RIP, routing information protocol, we have a two different version. One is RIP version 1, so which is right, and the other one is RIP version 2. So RIP version 1 is a classful routing protocol. RIP version 1 is a classful routing protocol. Right, it is going to support for the classless routing protocol, classful routing protocols, and that's why the RIP was upgraded from version 1 to version 2. In version 2, RIP is going to be supported as a classless routing protocol. Classless routing protocol. Right? In classful routing protocol, if you have a routers, two different routers, right? Router 1 and router 2, both the routers want to form the neighborship. They used to exchange the hello messages, and that hello messages are going to be exchanged with the help of these hello messages are going to be these hello messages are going to be exchanged with the help of broadcast, guys. So what is your broadcast? We know that to all 255.255.255.255. This is what the case in the RIP version 1. So that's why we have the RIP version 2. If you are going to use RIP version 2, so it is going to be support as a classless routing protocol, and so when to form the neighborship, it is going to be exchange the hello messages with the help of multicast address. That multicast address we have is 224.0.0.9, and the updates are going to be exchanged, the update, right? So the updates are going to be exchanged with the help of UDP port number 512, port number UDP port number 512, and we know what is UDP and TCP. So in the OSI model, open system interconnection, right? So in the OSI model, we have the 7 layers. In the 7 layer, fourth layer is the transport layer, transmission control protocol. Uh, in transport layer, we have a TCP and UDP services. Services are going to be identified based on the port numbers. Port What is port number? Sometimes as a fresher you will get the question, what is port number? Port number is nothing but it's a logical number, guys. Okay. And now the question for you, what is IP address? So our IP address is the logical address or a physical address? I'm just watching your chat, guys. Just let me know what is the IP address. IP address is the logical address or the physical address? See, try to answer. Try to answer. If someone asks you the question, try to answer. Or else you'll not going to be learn something new. So IP address is again logical address. Then what is a physical address? To which address we used to call as a physical address? Nice, Prasanna. Nice, Pallavi. Okay, IP address is the logical address, right, Rishita? I need to see you three guys messages in the group chat, like chat. Okay, or else I'll take your name. Okay, fine, fine, fine. So physical address is also called as a MAC address, right? So port number is called as a logical. Ports is nothing but a logical address, right? So total range of ports we have from 0 to 65,535. So when we join the live or when we join the class, right, we just need not to focus on the same topic. We have to be recall all the syllabus which you studied. So that's the reason I have taken like around 20 to 30 minutes to explain you what was we covered in the previous session and what was we are going to learn now, right? So that do take some time and try to revise those concepts, right? So we revise static route as well, and so while we are discussing this RIP, we revise this one as well, right? IP addressing. So in IP addressing, we have two different versions, right? IP version 4 and IP version 6. So in IP version 4, it's again classified into 5 classes. There is a class D, right? Class A, class B, class C is going to be used for the LAN and WAN purpose, that we are going to assign the IP addresses on the interfaces, right? So, but class D is reserved for the multicast. When we studied the IP addressing, we don't know why it is really you reserve a whole series of IP addresses. Like the class D is going to be start from 239 to 224 to, right, 224 to 239, right? So at that time we don't know why really the IEEE was reserved the class D IP address for this, right? So class D IP addresses for multicasting. Now you are going to understand. So to exchange, right, to form the neighborship each and every router. So whenever you configure the dynamic routing protocol, right? Okay. Uh, Hi Ayman, how are you? Right? So to form the neighborship, both the routers are going to exchange the hello messages. When it is going to exchange the hello messages, it is going to use the multicast address from this range. So from this range. So the RIP, so the RIP's multicast address range is 224.0.0.9, 224.0.0.9. So that's what I told you guys. Every class is very important. So whichever the class or whichever the live you are going to be joined, right? Be focused and do prepare a running notebook. Okay, this is going to be help you in the interview. So when you are going to crack the interview, so definitely interviewer is going to ask you this kind of crass questions for the freshers. See, for the fresher, he is going to ask you, okay, tell me about the types of routing protocols. Then you'll list down all the name, static, dynamic, and the default. And we have the different segregation in dynamic as well, IGP, EGP. Then he'll ask you definitely, okay, you will said that, okay, in RIP we have a two versions, RIP version 1 as well as RIP version 1 and version 2, right? So in RIP version 1, he'll definitely is going to ask you, right, what is the disadvantage in RIP version 1 and why we required to move from RIP version 1 to version 2. So then you need to list down these all points. So RIP version 2 is going to be support for what? It's going to support for the classless routing protocol, and it uses the multicast address. It uses the multicast address to exchange to become the neighbors to between the routers. So that's what the problem. But in RIP version 1, it is going to use the broadcast address 255.255.255. That's not the good actually. Okay. So I told you, right? So whenever there is a IP address, whenever you see dot zero, that is going to be considered as a network ID. So whenever you are going to see dot 255, in the last octet, in the fourth octet, right? That is going to be considered as a broadcast ID. So remaining only the in between from network ID to broadcast ID, that is are the valid IP addresses. Those valid IP addresses are you are going to be used. Those valid IP addresses are you are going to be used to configure on the end users or the interfaces, routers or switches. So that's why be familiar with the technology. So don't just you join in the half an hour and you tomorrow and you don't assume don't be any assumption that tomorrow you will get the job. Okay, so jobs are getting if you have a good understanding of the technology, good knowledge, like core knowledge. You should have a strong core knowledge. Okay, so whenever you get the question, you should have an answer for that particular question. Nice. Again, coming to the point. So we discuss about the functionalities, and this is also again important, guys. So RIPs are going to be exchange the updates, right? So updates are routing updates. So when it is going to exchange the routing updates, that update will contain only 25 routes. If the update is having a more than 25 routes in your routing table, if the router is having, see here. So in the routing table, if this particular router is having a more than 25 routes in his routing table, even this router will also have a more than 25 routes, then it used to send as a update in a multiple times, because in a single update it used to carry only a 25 routes only. This is again a gunshot point that you need to be remember, right? So the metric of the RIP is hop count, right? So hop count, what is hop count? To understand hop count, we studied about what is a trace route and what is ping. So if you do perform the trace route command, trace route command 8.8.8 as a Google DNS, it is going to show you right from your source machine to destination machine. If you want to reach from this particular source to the destination machine, how many hops that packet has crossed, so that the path information, the route information is going to be showing, right? So likewise in RIP also we have some the default, like the metric, like metric is a hop count, and the hop count is in RIP 15 routers, which means 0 to 15. If you count 0 to 15, the value will be 16. So if since from the source router it can travel, the packet can be traveled till to router 16 only. After the router 16, this is again interview question. So you will tell in the interview RIP is going to be support on the hop count. Okay, so the default hop count is supported up to the 15. So 0 to 15, which means it is a 16 routers, right? If it is a 16 router, so what will happen after the 16 router, that you need to be explained in the interview. Then it is going to showcase you that you have a good skills in the routing protocols, right? So after the 16th routers, guys, after the 16th routers, it is going to be dropped. It is going to be dropped. You will get the message in the source machine that the packet is dropped in the transmission, like in the transmit or the transmission, right? And the routing protocol RIP is also going to call as a routing by rumor. RIP is also going to call as a routing by rumor. So this is what the functionalities of the RIP. This is quite enough. Okay, when you want to, like, if you get any questions in the RIP, these questions are very these points are very familiar, like very good to explain you in the interview. Now, right, coming to the another point. So here we have, guys, right? So here we have like timers. What is timers? Why we require timers? RIP timers, right? So RIP timers. See, I'll tell you here. I'll draw the topology. Here I have a router one, which is connected towards my router two, right? For the first time, it used to send the hello message, right? The router used to send the hello message, and router 2 will also send the hello message to router 2. So once they exchange the hello messages with the help of multicast address 224 dot, right, 224.0.0.9, both the routers are going to form the neighborship. And you will see in the neighbors table that in R1's table, R1 is going to become a neighbor with R2, and in R2 router you are going to see that R2 is the neighbor of R1. So vice versa you are going to see in the both the routers, right? So once they form the neighborship, then it is going to exchange the routing updates, right? So they are going to exchange the routing updates with the help of port number UDP 520. So router 1 is going to send the routing updates. That routing update is going to be contain only the 25 routes. So whatever the backend network is there in the router 1, so that is going to send to router 2. Same likewise, router 2 will also send his network information, routing information to router 1. So till now we discuss here, right? Now, so there is a timers, guys. I'll tell you. I'll take you the other pen so that you'll understand. So in RAP we have a timers, right? So the update timer we have a different timers: update timer, invalid timer, and the flash timer. So both the routers become a neighbor, and each neighbor, like in R1 you will see the R1 is the neighbor of R2, and in R2 you will see the neighbor of R1. So here we have a timers like update timer, invalid timer, and the flash timer. Consider if this link, right, the router 1 and router 2 will have a continuously communication or the heartbeat between the both the routers. See, for that it is going to be used the update timers, the timer between two consecutive updates. Okay, so it used to exchange the hello messages between each other like in every 30 seconds, every 30 seconds. That is what the update timer. Invalid timer means what? Invalid timer, the timer a router waits to hear the update from the neighbor router. Okay, so this is router 1 and router 2 is going to become a neighbor for router 2, right? So that's what I mentioned here. So router 1's neighbor, who is going to become a neighbor to router 1? Router 2 is going to become a neighbor of router 1. Likewise, router 2 is going to become a neighbor of router 1. So if router 1 send the hello messages, right, every 30 seconds, it used to exchange the hello messages. If connectivity is fine, then he send the hello messages within that 30 seconds. Router 2 will also send the hello message to router 1. Now consider there is some issue in the connectivity. There is some issue in the connectivity. Like this link got down. This link got down. So router 1 sent the hello message to router 2, but router 1 didn't get the response from the neighbor. Router 2 is the neighbor of router 1, right? But this router 2 didn't get the response from hello message response from router 2. So that router 1 is wait till 180 seconds, right? The router is marked as unreachable. It will wait till 180 seconds, and router 1 is going to mark as a router 2 is unreachable. There is no update from the time period within 180 seconds, which means first message used to send in 30 seconds. So like this, 30 into 6, right, 180 seconds. So 6 times it used to send the hello messages. If 6 times the router 2 didn't get the reply within the six messages, if the router 2 didn't get the reply from this neighbor, then after the 180 seconds, router 1 is going to mark as a router 2 is unreachable. Then after that also he'll wait till 240 seconds. After that also he'll wait till 240 seconds. That is called flash timer. After 240 seconds, okay, after waiting of 240 seconds also, if the router 1 is didn't get any response from router 2, then it is going to flash whatever the information. See, router 2 has exchanged his routing information to router 1, right? As an update in the 25 update, 25 routes are going to be sent in the update. So that update was installed in the router 1's routing table. So after waiting a 240 seconds, after expiring the flash timer, then see here the time after which the invalid routes are removed from the routing table. So whatever the updates or the routing information router 2 has given to router 1, that is going to be installed in the router 1's routing table, right? So after he wait 240 seconds, even though if I didn't get the response from 246 within 240 seconds from this router 2, what I'm going to do, I'm going to flash this particular routing information, routing updates, whatever I learn from router 2, because router 2 itself not reachable, right? If it is not reachable, why I required his routing information? So that's the reason I'm going to flash that particular routing information. Then all of a sudden, right, after 1 hour or 20 minutes, as a network engineer, you guys has to troubleshoot. Now you will come into the picture. So now what you need to do, so you need to identify that, sorry guys, you need to identify that why this particular link got down, what was the issue, why the neighborship was break between router 1 and router 2. That is what the troubleshooting. Okay, that is what the troubleshooting. You need to log in both the routers, and you need to verify the logs, and you need to debug the logs. You need to debug the logs, what exactly is going to be happen between the routers, whether the hello messages, see, router 1 is sending the hello messages, that hello message is trying like reaching router 2 or not, or else router 2 is sending the hello messages to whom it is sending, whether it is sending to the router 1 or the other routers. That's how you need to verify the troubleshooting in the live infrastructure, guys. So Again, interview perspective, this is very important. You guys has to be remember RIP is going to maintain the three timers. One is update timer, and the second one is invalid timer, and the flash timer. So update timer is 30 seconds. The invalid timer is 180 seconds. The flash timer is 240 seconds. If within 240 seconds, both the routers are not getting a message, okay, okay, if within from the both the routers in between 240 seconds, if they didn't get the message like the like replay message, hello message replay, then it is going to be considered as a the flush timer. The device is not reachable, the neighbor is not reachable, so I'm going to flash the information whatever I get from my neighbor, so I'm going to flash that particular information. So this is what timers, guys, this is again important when you are going to troubleshoot. Sorry. Now we'll discuss about the advantages and the disadvantages. Okay, what is the advantage and the disadvantage of the RIP? Every routing protocol will have advantages and disadvantages and the use cases. That's what I told you. See, whenever you are going to study any routing protocol, always focus like what is the advantage, what is the disadvantage, and what is the functionalities, and what is the use case. In which scenarios we are going to use that particular protocol, right? And which scenarios we are going to use that particular future. So that's how you need to be always. That's how you need to be always be prepared for the interview as well, for your knowledge as well. Now, so static routing advantage and disadvantage. Okay, secure because okay. So guys, this is a static routing, guys. Okay, so I was prepare the static routing, right? So this advantage and disadvantage for the static route. I'll tell you what is the advantage and disadvantage. Yeah. See, in your organization, if you have 100 or 1,000 routers, okay, 1,000 routers, is the static route is a standard solution? Can we configure static route or the dynamic route? So which one is better? If you want to configure a static route to form a neighborship between the routers, you need to configure 1,000 static routes. Yes, you need to configure 1,000 static routes. You need to configure 1,000 static routes, which is not a feasible solution in the production network. So that's the reason we are going to be configured the dynamic routing protocols. So in dynamic routing protocols, today we discuss like RIP, right? The first protocol, RIP, routing information protocol. So compared to static, if you go with the dynamic routing protocols, you just need to introduce your directly connected interfaces network only. See here we have interfaces, right? So whatever the IP you are going to assign in this particular interfaces, that interfaces IP address network ID you need to be configured on the routing protocol. You need not to know about the destination network. What is the destination network? I don't want what is the destination network. I can configure the routing protocol without knowing the destination network. Also, you can configure the dynamic routing protocols. But the disadvantage in the RIP, guys, compared to other dynamic routing protocols, RIP is going to be support the hop count is the maximum hop count till 15 only, which means the data used to be transmit or the travel. The data used to be taken care till the 16 routers. After that, it is going to be dropped. That is again a very big disadvantage in the production networks. So generally, we will have a large infrastructures like head office and the branch office kind of setup. Head office, branch office, like the multiple sites we have. But when you are going to configure the RIP in the production networks, it is going to be like if you are a small organization, then it is okay, fine. But in the enterprise network, RIP is the not good routing protocol. So we have the EIGRP and OSPF and BGP for that for the enterprises network, right? And one more disadvantage is we have only 15 routes, and the one more disadvantage is it is always going to be do the equal cost load balancing only by default 4 paths. But we have the other routing protocols as well. That routing protocols are going to be do the load balancing. That routing protocols are going to do the load balancing, equal and unequal cost load balancing. So this is what your like RIP, guys. This is what your RIP. I hope I mentioned somewhere like I created the syntaxes as well, but I prepared the syntaxes as well, but I don't think so where it was. Okay, so somewhere I kept, but fine. So whenever you have this kind of topology, you need to be configured. So earlier, let me remove this so that I'll tell you one thing so about the RIP. So now you need not to know about the destination network. So whenever you are going to be configured, whenever you are going to configure any topology, right? Okay. whenever you are going to be configured the RIP routing information protocol, what you need to be focused, you need to be always focused that, right? You need to be focused, just introduce only directly connected information, only directly connected information, guys. Okay. So now, so before you configure that, right, you should know how the RIP is going to be configured, right? Okay, how the RIP is going to be configured. For that, we have a syntaxes, right? So for every configuration, we have a syntax. For every configuration, we have a syntax. So we used to follow that only, right? So we know that what is the syntax for RI? Sorry, this one like static routing. So to configure the static route, the syntax is IP route, right? IP route and destination network ID as well as the destination subnet mask, and either we can use exit interface as well as we can use the next hop IP address. So based on that, we can use anything, right? Based on your convenient. So to verify the routing protocol, like to verify the routing table, so the command is show IP route, right? So to verify the routing table, the command is show IP route. So once you configure the static route, guys, so in the routing table, you are going to see that route information as a yes. Yes stands for static, right? So that we understand from the static routing. Show IP route is a command to verify. So in both the routers, you are going to be verify show IP route. So likewise in RIP also we have it. Like in RIP also we have like what we have this one, right? In RIP as well we have syntax, guys. So before we understand any configuration, we should know what is the syntax or how the syntax used to be work, right? So if you understand the syntax, then configuration part is very easy. So we'll go here. Okay. So fine, guys. So let me write down the syntax here. So something is missing. So I don't know this. 92.168.1.0/30 I'm going to use here. So 1.30/30 here and 1.2/30 here, right? So to know the configuration, so the syntax is first by default, guys. So you need to go into the global configuration, right? So RIP, I'll mention here RIP config syntax RIP config syntax. The command is, so once you are in a global configuration, consider you are in a router RTR, right? You are in a RTR. So you are in a router in a global configuration. Here you will see like config. So you are in a global configuration. Now you need to be used, guys, IP routing. By default, you will use IP routing, but the thing is router RIP. The command is router RIP, which protocol you are going to configure. Then you need to specify the version, either version 1 or version 2. Then you need to specify network space. Then here you need to specify the network ID, network space, network ID, then exit. That's it. This is what the RIP's configuration syntax. If you understand this syntax, it would be okay. If you understand this syntax, it would be very easy you guys to be configure any routing protocols, any dynamic. Sorry, the RIP routing protocols. If you see here, guys, generally, okay. If you see here, but we have, so first we need to use, once you are in a global configuration, you need to use router RIP. Command is router RIP. It's not a case sensitive, you just need to use the capital RIP only. You can use anything, you can use small RIP also, both are same. Okay, so router RIP, right? Router RIP, then version. So which version you are going to be configured? If you configure version 1, both the routers are going to form the neighborship, right? And to exchange the messages, it is going to be used the broadcast IP address, right? 255.255.255. And once you configure the RIP version 1, it is going to be it is going to be act as a class full routing protocol, right? It is going to be act as a class full routing protocol. If you use RIP version 2, then it is going to be exchange the hello messages with the help of multicast address, and the multicast address is 224.0.0.9, right? So it is going to support for the classless routing protocol and network space network ID. So this is what the thing you just need to remember here. Remaining all the things are same in all the routing protocol. See how many networks we have. So here in the LAN side, we are going to use 192.168.1.0. In the WAN side, this is our WAN, right? So in the WAN side, what network we are going to use? We are going to use 192.168.1.0. So how many networks do you have? That many times you need to repeat this command, guys. How many networks do you have? That many times you need to repeat this command. Network space network ID. Okay, network space network ID. On the basis of this configurational syntax, guys, on the basis of this configurational syntax, I can write down the configuration how I used to be configured. So first in router 1, I'll go into the global configuration mode. Then I'll type here the command is router RIP. Then I'll type version, which version. So I'll always prefer the advanced version. So I'm going to use version 2. Then here I have in my LAN I have a network. So this network I'm going to call here. The command is a network space. The network ID is 192.168.1.0. Even though in WAN side also I have a network. So this is my WAN network, right? This is my WAN network. So I need to repeat the network command one more time, like network space, and the network ID is 172.16.1.0. Right. So once I type this command, then I'll come exit. This is what the RIP configuration in the router 1, guys. This is what the RIP configuration in router 1. So once you're done here, right, then you will do the same type of configuration in router 2. But the thing is here it is going to be changed. What it is going to be changed in the network side, like in our router 2 also you are going to configure router space RIP version 2 network space, and the network ID you are going to use this one, right, 192.168.2.0. Then in the WAN side, we are going to use same network, right? So this is the same command you need to be repeat. So once you configure this, right, router 1 and router 2 are going to exchange the hello messages, right, with the help of multicast to form the neighborship, right? So once you configure this, to verify you can check that the command is show IP route. So once you type the command show IP route, right, in the routing table in the routers, both the routers, you will see this 2 dot network 2.0/24 network that you learn in R1 as a R and 2.0/24. This is how you will see in the router 2. So I'll do one thing. Okay, so hope the syntax was you understand the syntax. I'll quickly configure the lab. So this is what our lab, right? So this is what our lab. So yesterday we configured something. Let me check what we configured. And okay, I think configuration was removed. Let me see. No, I'll take this router as well. I'll form the neighborship between three routers. You will see how we used to be form the neighborship between the three routers. And now I'll open this router as well, guys. So I'll do the quickly configurations. Show IP and brief. What IP addresses we have? We have okay, fine. So if I want to check, show run interface F80/0. So okay, /32/30 I'm using here. The /30 subnet 255.255.255. Fine. So I don't want to do any changes here. Okay, so here we have a routing, right? Static route. Let me check in the router 1 as well. So this is my router 1. Router 1 is this, guys. So if we check here, so show IP INT brief. Okay, so I have this interfaces and there is no IP addresses configured on router 1. Fine. Show run. Okay, I'll do the. I'll check the routing information. Show IP route as well. Do you have any routes? We don't have. Do you have any route static? That is also I'm going to check. Show IP route static. So I don't have any route information here. Fine. And what is update in the router 2? We'll verify that router as well. Enable show IP brief. Brief. Okay, here also I don't have any configuration. We have only in router 3. You will see here. See in the router 3 we have the IP addresses configured already. Show IP brief. Right. So there are two interfaces on FA0/0, which is going towards router 1, that is configured, and the LAN interface is configured. The remaining is not configured. So if you want to do, if I want to do one by one, line by line, I can do. Or else we have the configuration, right? We already prepared yesterday the configuration, guys. So you know that this is how we used to use the notepads. So I have the configuration of router 3. So this router 3, so that is already in place, so we don't have a configuration in router 1, right? So what I'll do in router 1, so this is what the thing we identified, right? Let me take this now. So see here, guys. So in router 1, here we are going to configure LAN interface. So this is a FA1/0. So this is my FA1/0 IP address. We decided 1.1/24. So we have configuration and no shutdown as well. Fine. And we have another interface with towards going R3. So FA0/0, we have the IP address 172.16.1.1/30. It is a /30 actually. So /30 subnet is 255.255.255.252 and no shutdown. So we have another interface FA2/0. FA2/0, we will assign here 172.17.1.1/30. So for that we will prepare the script. So nothing, I'll just copy that. Okay, I'll just copy this script. See here. So what is it in router 1, right? In router 1 configuration, what I need to change, I need to see FA0/2, right? In fast Ethernet FA2/0, okay, 2/0. The IP here we decided 172.17.1.1 and the /32. Everything. Router 1's configuration is fine, and router 2's configuration, router 3. So this is router 3. I'll do one thing. So I'll copy this, guys. Okay, till here, and I'll modify here. See how we used to modify the configuration in the notepad. So this is the router 2 configuration. So in router 2, what IP address we have, let me open my lab directly. You can see here now. So this is our router 2, right? So in router 2, we have a FA1/0 first interface, FA1/0. Okay, fine. So here we decided 2.1 IP address. So I'll just modify here 2.1 and 255.255.255.0, right? And we have one more interface FA2/0. So I'll mention here fast Ethernet 2/0, 2/0, and the IP address is what, 172.17.1.2, 17.1.2. And the IP address is fine. So this side I have one more interface FA0/0, FA0/0. I'll assign here 18, right? 172.18.1.2. See how simple I prepared the configuration for router 2. If you have a good understanding, you can easily prepare. So likewise, in router 3 we have this is the syntax. So in router 3, configure terminal, okay, FA0/1/0. We already have 192.168.1.3 IP address. Even in the FA0/0, which is towards connecting towards my router 1, there also we have IP address. So we just need to be copy this interface, and here I need like FA. What is this interface? FA2/0, right? I'll mention here FA2/0. Then what was the IP address? 18.1. 18.1. 18.1, guys. 18.1. See, this is what my configuration. If I want, I can directly copy and paste. Everything will come into the. Okay. So we know that the basic configuration we need not to perform. You already know. So I'll just copy this router 1 configuration, and I'll go into the router 1. You'll see here. This is my router 1. I'm pasting here. See, done. Exit. Write memory. Right. So I just copied that. Now if you check show IP interface brief, you will see the IP addresses. We have three interfaces and respect to the interface. First interface is fast Ethernet. First interface is fast Ethernet 0/0. Okay, fast Ethernet 0/0 is something got wrong, buddy. Sorry, yeah. Fast interface is fast Ethernet 1/0, right? So in fast Ethernet 1/0, we have the IP address 192.168.1.1. Here also we have the same thing. And the next interface is FA0/0. Here we decided 172.16.1.1. So fast Ethernet 0/0. 16.1 we have the IP address, and here the other interface FA2/0. In FA2/0 we have the IP address 172.17.1.1. Here also we have the same thing. So we done the configuration. The basic configuration is fine. I don't want to like modify anything. So I'll I'll configure the hostname for this. Okay. Okay. So something. One second, guys. Okay. 1 second, guys. Just give me. Okay. So 1 second, guys. Okay. I just got the message from. I just got the message from one of my colleague, my friend, senior. Okay. So. Okay. So. Yeah. Hey, 1 second, guys. So you will get the chat, Ajay. You need to just subscribe. Okay, if you subscribe, then only you will get the chat. Do send now. Do send now. You will see. You will see that. Do send. Okay, Ajay. Let me continue here, buddy. Send me the snap. Send me the snap. Okay, Ajay. I'll take you. I'll take you that in 5 minutes. Huh? Okay. We'll talk in. Like, thank you. Okay. Yes, buddy. So we done about our router one, right? So router one configuration is done. So let me set up the host name as well. Host name. So here we have the host name is RTR1. So down this router, right? Everything is fine in router one, right? So I'll minimize this router one and I'll take router three. So router two, I'll take router two. So this is my router two. We don't have any IP address here, and we prepared the script in route for router two as well. I'll just copy that script from router two. So this is my script, right? So there are three different interfaces, and we configured that. Control C. Okay, just copy from your notepad. So this is how we used to do in the CCNP and CCIE level, guys. Okay, because we will not have a time, so that's a reason to minimize the time. We used to do the labs like this. Okay, so I done a router 2's configuration also. If you check now, all the interfaces will have IP address. Show IP INT, show IP INT brief. So in show IP INT brief, Ajay, uh, already in chat. Okay, Ajay, looks like Ajay, right? Okay, yeah, yes, Ajay, it's working fine for you, right? Nice, nice to hear that. Okay, so see, guys, now here we have the router two. In router two, guys, right? Whatever the IP addresses we decided, show IP INT brief. So you will see those IP addresses in router two's FA1/0. FA1/0, you will see that 192.168.1.2.1. So that is what your IP address for the LAN, and for the WAN, which is connected towards your router one. So the interface is FA2/0. So in FA2/0, you will have the IP address 172.17.1 dot. Okay, okay, 1 dot. Okay, 1 second. Right. So here we will have a 1.2. So likewise, the one more interface which we are connecting towards the router 2. So that is also there. So I'm using right memory command to just save the configuration. So this router we are going to configure the name as a router 2, right? Router 2 configure terminal. The command is host name. So here you will mention RTR2, right? Just come exit and save the configuration. Save the configuration. Everything is done. So I'm minimizing router 2 as well. Now I'll take router 3, guys. So here you will see show IP INT brief. So here we have only two interfaces. We need to configure one more interface. So for that we already prepared the script, right? So in router 3, this is the only thing we need to be configured. This is the only thing we need to be configured. Okay, let me copy this so that I can paste in the router 3. So this is my router 3. So first I'll configure like host name in configure terminal. Okay, so you will see here, guys, configure terminal. The host name is what we decided, RTR3. So once you type that command, I'll just paste that command, like whatever I copy, right? I used to paste. I think I didn't copy. Let me copy this. If I paste here, command, something is not working, guys. Something is not working. Okay, what is the interface 2/0, right? So 18.1, yeah, that's fine only. So it is not copying. Okay, so interface, yeah, fine, it's copied now. Now if you check, right, so you will have a three interfaces with IP address. So IP ID brief. See all the interfaces we have the IP address. So now I'll save the configuration. Now I'll take a moment and to explain you guys. Okay, so as we discuss, guys, let me take the full topology. So we done about the basic configuration. We done about the basic configuration. We don't have any issue in the basic configuration. Right? Let me take my pen as well. It's very kept, man. See here, guys. So in the router one, so this is our RTR1, and this is our RTR2, RTR2. This is our RTR3, right? So in all the routers, we done the basic configuration. We configured the host name and respect to by the interfaces. Each and every interfaces, we done the IP address assignment. If you try to ping, since from here, ping space like your default gateway, whatever the default gateway you have, like 192.168.1.1, you will try to reach till here, guys. You will reach till here. Even since from this laptop also, or this machine also, you will try to reach your gateway. From here also, you will try to reach your gateway. But the thing is, when you try to reach from this machine to router to this machine, you are not able to reach. Okay, even though if you try to reach from here to router 3's LAN, so you're not able to reach because we don't have a routing in the process. Here we don't have a routing in a process. So we don't have a routing. So you can consider, you can configure static routing as well, static routing protocol, or else you can go with any dynamic routing protocol. So if you configure static routing protocols, what is the issue? I'll tell you what is the issue. See, so since from here to in this direction, you need to configure one route, and in router 1 to in this direction you need to configure one route, like one route and two routes. Then you are in a router 2, guys. Now in this router 3 you need to configure one route towards this direction, means 3, and you need to configure one more route this direction, 4. Okay, 4 routes. Now you are in this router, so you need to configure one route towards this direction, so 5, and you need to configure one route towards this direction, so 6. So to communicate fully in this topology, what you need to do, so you need to configure, you need to configure 6 routes, 6 static routes. So we have a 3 routers, right? So even though if you have a 3 routers, you are configuring 6 routes. If you have 1,000 routers, guys, 1,000 into 2, like 2,000 manually routes you need to configure. So that's why I told you static route is not the solution for here. So what is the solution now? So we can configure any dynamic routing protocol, right? So as we studied today, RIP, right, routing information protocols, we will do the RIP slab. We will do the RIP slab here. So what we need to do, once we log in this particular router 1, right? So once we log in this particular router, we just need to introduce our directly connected network information. So in LAN side, I have 192.168.1.0 network. The WAN 1, consider this is my WAN, this is my WAN 1, okay, and this is my WAN 2. So in WAN 1 side, I have the network is 172.16.1.0. In WAN 2 side, I have the network is 17.1.0. So only these three networks I need to be give. So what I'll do, right? See, again I'll take the notepad, because notepad is very easy, guys. Because when we tried our CCNA, right? When we do our labs in the CCIE, so this is how we used to do. So what is the syntax we decided? The syntax is, once you need to go into the global configuration. So the command is what? Configure terminal. Then you need to type router RIP. Then you need to decide the version. So I'm going to use version 2, right? Then you need to specify the command network space the network ID. What is the LAN network ID? The very first network ID is here. We have what for the LAN? So 1.0, right? So here we have a 1.0. So that's the reason I'm going to mention here network 192.168.1.0. Enter. Then again I need to repeat the same command, network space 172.6 WAN 1 network, guys, 172.16.1.0. This is my network ID. Now again for WAN 2's network ID. So what is a WAN 2 network ID? We decided 172.17.1.0. That's it. Exit. This is what the configuration I need to do in router 1, guys. Router 1. So this is the router 1 configuration. The same thing if you go here, right? So in router 2, guys, let me do one thing. Let me open the lab itself directly. See here you have a router 2, right? So here we have how many networks? Let me take the other pen. Okay. So in router 2 we have 3 networks again. In router 2, this is my router 2, right? So again you will go router RIP and the version 2, and the networks here you need to type 192.168.2.0. One network, this is LAN network. Another, here we have one WAN network, so 172.17. network. So I'll take here 172.17.1.0. Here we have a 18 network, right? So here you need to type 172.18.1.0. That's it. So this is what the network which you need to be introduced, which means directly connected interfaces. So whatever the interfaces you have directly, right? So on that interface, the IP address, network address, you need IP's network ID you need to specify. That's it. Nothing more rocket science here. So what I'll do, right, for router 2, I'll just copy the same configuration. Okay, I'll paste here. Okay, so in router 2 version 2, okay, what is the network? The LAN network is 192.168.2.0. So I'll modify here. Then one more LAN network is the 18.172.17.1.0. Okay, the other network is 172.18.0, right? That's it. So router 2's configuration also done, guys. Router 2 configuration also done. So now what we will do, we will prepare the router 3's configuration as well. This is our router 2 configuration. See, this you need to do manually first, like by with your hands. Okay, once you become a familiar, guys, once you become a familiar, then you will see you can do, like, once you become very much familiar, then you can use the notepad. So first you don't use notepad, so do configure by one command, because I am very much familiar with my technology, so that's why I used to teach you guys with the help of notepad. So but you don't do in the notepad. Okay, so what I'll do now, so what networks we have in the router 3? In router 3 we have the LAN network. First LAN network is 192.168.3.0. Okay, and the another WAN network is 16.1.0. So 172.16.1.0, and here we have 18 dot, right? So 172.18.1.0. So this is the networks which we need to be configured in this router. So this is in this router, this is in this router. So that's it. This much of simple, guys. So that's why I told you. So to understand, you should have a good understanding. If you have a good understanding, then you can configure any routing protocol. At least you should have any one routing protocol understanding. Very good. See, I'll take here 3.0. Done. And the other point is 16.1.0. Okay, the other one is 172.18.1.0. So this is what my all routers configuration. First I'll configure this. First I'll take this routers 1 configuration. I'll open router 1. So this is my router 1. I'm in a privilege mode. What I'll do here, so in the privilege mode, I'll just copy my configuration. Just hit enter. That's it. I did my configuration here. So likewise, I'll copy this configuration, like router 2's configuration. Let me copy this. Control C. So I'll go into the router 2. It's a router 2, right? So this is my router 2. I'll just paste here. Done. You will see some magic now. See, by seeing a few of the neighborship will come up. You will see. I'll not type hit any enter. So once you are going to see here, one of the neighborship has come up. The messages you are going to be see here. So in between we will do one thing. So we will paste the configuration of router 3 as well. Then you will see you are going to be see. Okay. C. So where is my router 3? So my router 3 is here, guys. Okay. So this is my router 3, right? So I don't want to do anything. I just copy and paste. Now exit. I'll save the configuration. Here also I'll save the configuration, right, ma'am? And even in the router 2 also I'll save the configuration. So I did all the configuration. So as we expected, as we discussed, right, all the configuration I have performed, the RIP related configuration. Now, if I try to reach since from here to this PC, I can able to reach. Even I can able to reach this network also. So vice versa, anything can reach anyone now because we formed the routing protocol. We already configured the routing protocol. To verify which routing protocol we configured, right? The command is show IP protocol. Show IP protocol. So this is the command to verify which routing protocol is running on the going on the router. To verify that, we need to run this command, and to verify the routing information whether this routes 2.0 and 3.0 routes are 2.0 and 3.0 routes are learning or not in this particular router 1. So to verify that, we need to run the command is show IP route. So IP route. Show IP route. By using this command show IP route, you will see that by symbol R, I'll show you. So now see, we configured all the routers as a RIP version 2 here. Here also RIP version 2, right? So even here also we configured RIP version 2, right? So now we will verify which routing protocol we configured in all the routers with the help of this command show IP protocol. So I'll open first router 1. So for that, we will minimize the other routers or else you will get confused, guys. So I'll open this router. So this is my router 1. This is my router 1. So I'm in a router 1. Okay. So I'm in a router 1. The command is show IP protocols. If you type this command, see what you are going to see here. So when I type show IP protocol command, it is going to show you. Okay. So the routing protocol is what? The routing protocol is RIP that you configured. And so which are all the interfaces are going to be participate in this routing protocol. So here we have a 3 interfaces. So these 3 interfaces are, guys, this is important to do listen very carefully because this is very important because most of the guys don't know really in the production networks, so they don't know how to verify. And even though they verified, right, so what really the meaning of that like that command they don't know. So do remember and do listen very carefully. So once you type the command show IP protocol, so it is the router is going to show you that so what routing protocol is running on that particular router. So in our router 1, so the protocol is RIP is going on. And in router 1, so with how many interfaces we have introduced in RIP. So we introduced 3 of the interface. See here, FA0/0, which is connected here, like, so which is going towards router 3, yeah, router 3. And we have introduced one more interface, FA1/0, which is going towards our LAN switch. And we have introduced like 2/0, FA2/0, which is going towards the other direction. So this is what, right? See, guys, so this many interfaces we introduced, 3 interface. And what networks we configured here. So if you see here, right, so if you see, shit, I mentioned, right, I removed that one, right? Okay, no problem. See, we configured network space network ID 1.0 and 17.0 and 16.0. How many networks? 3 networks only. 3 networks we introduced. So even we have in a notepad, right? In our notepad we have that. So in router 1, what is the configuration of RIP? We configured this one, right? 1.0, 16.1.0, 17.1.0. The same thing you are going to see here. So whatever you introduce, right? So the same thing you are going to see here. And a routing information source. So since from where you are getting learning the routing information, it is going to tell you from where you are going to be learn the routing information. See, one of my interface which is going to be connected router 3, right? So this interface is going to be connected towards router 3. And what is the subnet here? The routing source information. So this 3 dot network, see, this is very logical thing, guys, even very important actually. So most of the guys will don't know. See, when I check the show IP, sorry guys, when I check the show, come on. See, I check here in this router 1 show IP protocols, right? Protocols. by using this command I am getting I used to get to know, right, the RIP is going to be work and what are all the network information was introduced in this routing protocol, that also I got to know. And from this 3.0 and 2.0 network I used to learn, right? So from where I am getting to learn that information, that is also I used to see from this router one. See, this information I used to get from this particular IP address, whatever you configured here. And this 2.0 information, I used to get this 2.0 network information in router 1 with the help of this IP address. That is what we have here. You can see. Okay. So the source of the information, routing information source. What is the routing information source? So one is 17.1.2. So where is 17.1.2 here, right? See, in router 1, you used to get this network information from 17.1.2. So that's what I am showing here, right? 17.1.2. The other source of information is what, right? Other source of information 172.16.1.2. So where is that? Here. So to learn this network and this network, from where we are getting to learn, this is the source of information, source of information. So that's how you need to be verify in the production networks. One more thing, guys, one more point we discussed, right, that RIP is going to be to the load balancing maximum 4 paths. You can see here, that is here only, maximum path. The maximum path of load balancing is 4. So that's how we used to be right. So we used to be like identify in the production networks. Now I'll show you. If I type show IP route command here, so we discuss show IP protocol, so everything is clear. Now I'll show you one more crazy command, that is a show IP route. So by using this command in router 1, show IP route, so if I use show IP route command in the router, you will see what logic is going to be happen, what logic is going to be happen. So I'm going to get the routing information of 2.0, how to reach 2.0, how to route 3.0. So I'll get this network information in router 1. So I'll open router 1. This is my router 1, guys. So let me type enter show IP. First I'll maximize the screen. Okay, show IP route. If I type this command, you will see here I used to get the information of 2.0 network and 3.0 network. R stands for what? R stands for RIP. See here. So I'm learning this route 2.0 and 3.0 network information via the next hop IP address since from this time. Okay. So even I'm going to learn this time. So if I want to check only RIP routes, C stands for connected routes, L stands for local routes. 192.168.1.1.0 network you will see here. See, connected and local, because we configured in router 1, right? So that's why you used to see as a local 1.1. Okay. Now if I want to check only RIP routes, not I don't want this much of routing information like routing table in my screen. If I want only RIP routes, then the command is show IP route. Okay, show IP route. What is the command? Show IP route RIP RIP. See, you will see only the RIP's information here. So instead of you are getting this much of a complete whole routing table, okay, connected and the local routes, by using this command show IP route, you are going to show IP route RIP, the special thing. Okay, you are going to get only the RIP routes only. See here, so we are getting the route of 2.0 information as well as 3.0 network information. If I want to ping, I can ping from here as well. So that's how you need to be verified, guys, each and every router. So we are in router 1, right? So we are in router 1. Whenever we verified this in router 1 show IP route, so we are getting 2.0/24 network and 3.0/24 network, so that it this users, whenever my LAN users, like consider the source IP is 1.1.10. This guys, source IP is 1.10. Okay, and the destination IP is what? So if my user wants to reach 2.10, this packet, right, this data used to hit to the gateway first, right? So here in the router, so my router will check the routing table, show IP route. So whether do you have a route to reach 2.0 network, because my LAN user wants to reach 2.0, right? 2.0 network. So router will check the routing information. When it check the routing information, yes, we have a routing information here. So this 2.0 network we are learning via from this IP address like 172.17. 1.2. So yeah, fine. So my router used to send that packet to this particular router, and this router used to send to the LAN side. That's how the communication used to be work. Now I'll tell you the craziest part. So in router one, we are in router one, right? So we are in router one. We are getting the information of 2.0 and 3.0 network information. So likewise, guys, if you are in router two, if you check show IP route command in router two, show show IP route command in router 2. So you will get the information of 1.0, like 192.168.1.0/24 network, and you will get the 3.0 information as well, 192.168.3.0/24. And here in this router, if you run the same command show IP route in router 3, so this router will know the information of 1.0, like 192.168.1.0/24, as well as 192.168.2.0/24. We'll do the same thing. We'll repeat that in each and every. Okay, we'll repeat that command. We'll repeat that command in each and every router. So here in router 1, RTR1 we verified, and we are able to see this one. So likewise, we are going to be verified in RTR2. Okay, once we confirm that, then we will jump into the RTR3, guys. So that is what I'm trying to explain you. So let me open my router 2. So if I want to verify only the RIP route, what is the command? Show IP route, show IP route RIP. So once you hit enter, so as I discussed you in router 2, what routes you need to be get? You need to get 1.0 and 3.0. See here, you are getting right 1.0 and 3.0 routing information, right? So we are here. So likewise, if I take router 3, so in router 3, guys, again the same thing, show IP route RIP. So if I type here, so what routes we need to get here? We need to get 192.168.1.0 and 2.0, but we are getting only 2.0 network. Why we are not getting 1.0 network? Something mistake is there. Some issue is happening. So now here you need to troubleshoot what was happened. What is the issue? Okay, so how we are going to be troubleshoot? Can anyone let me know how we are going to be troubleshoot? But in router 1, we are getting 1.0 and 3.0. In router 1, we are getting, this is my router 1. So IP route RIP. So in router 1, we are getting 2.0 network and 3.0, which means this 3.0 network router is trying to, this router, right? So this router is trying to give this network information, but here in this router we are not getting 1.0 network, which means there might be some configuration mismatch between this interface. You will see that there might be some configuration mismatch in router 1 and router 2. So take router 1 first. So this is my router 1, will kept here. Okay, show run pipe section RIP, what configuration we done in RIP, and here I'll take the router 3. So this is my router 3, right? Show run pipe section. This is the advanced command of troubleshooting. You guys need to be learn these things. Okay, see I mentioned here 172.16. Okay, 0.0. Okay, fine, and 17.0.0. Okay, this is my LAN network, and here also we have, okay, fine. Okay, what is our configuration? Show run interface FA0/0, enter. Fine. Here, show run interface FA0/0, enter. Okay, 252 and 72.16.1.2, fine. All good. So I am able to ping this guy 192.168.192, guys. So what is the configuration? 172.16.1.1. Yes, I'm able to ping, and vice versa. Let me check once again. Okay, show run interface, show IP anti-brief, IP anti-brief. So interfaces are fine. 1.2, 172.16.1.2. So what is the subnet must be is here VS 252, and here also 252. Yes, fine. So IP route. So do you have 1.0 network? Yeah, we have. What is the issue, guys? So the issue is, see, that's how we need to do the troubleshooting. Okay, So troubleshooting is very important, guys. You should learn the troubleshooting always. You should learn the troubleshooting. Without troubleshooting, see configurational. You can see by seeing the commands also. You can do. You can see here. I'm learning this 3.0 network, right? Show IP route 192.168.3 consider 3.10. So this I'm learning via this interface fa0/0 from this interface, but I'm learning here. How I'm learning here? I'm learning okay via RIP. If I type here, okay, show IP route and 192.168.1.10. So this route I'm learning from static. See this one dot network. See where is the one dot network? Here we have a 192.168.1.0/24 network that I'm learning from static, not the RIP. So because there is earlier there is a configuration. If you want to check that configuration, see pipe section show run pipe section static, right? No, not this command, guys. Show IP route static. If you see here, there is a static route is configured previously for this network. There is a static route is configured previously. Okay, there is a static route is configured previously for this network. So that's why we are not learning 1.0 network here in RIP. So if you see show IP, yeah, show IP. Come on, guys. Show IP route RIP. If you see here, we are not learning the 1.0 network. We are learning only 2.0 network. I'll remove the static route. Then you will see by default it used to learn, guys. By default it will learn where from RIP. You will see that. Okay. So to remove that, first I need to verify the static route. Show run pipe section, right? Static. See, I'll get the static route here. So run section static. No, I'm not getting. Where is this one? Show IP route static. This is a command. So this is the route, right? So I'll remove this route. Configure terminal. No IP route. No IP route. What is the route? No IP route. 192.168.1.0. This IP address and the subnet mask is 255.255.255.0. Okay. See now, if you see the same command, do show IP, do show IP route static. You will not have any routes, so I'll just save the configuration. I remove the route, guys. I remove the route. Now what I'll do, right? So I'll do one thing. So what I'll do, if you check now the routes, show IP route, come on, show IP route RIP, you will see the 1.0 route now. See, you will see the 1.0 learning via route. So the same command, show IP route, right? Show IP route 192.168.1.10. If I hit this, so now see 1.0 network I'm learning via RIP. I'm learning via RIP. And what is this 120, guys? What is the 120? What is the AD value of RIP? The AD value of the RIP is 120. That is also it is going to be show. Earlier it used to show as a 1. You can see here. So when I check the route, right, the route information, you will see the route information here. Where is it? Show IP route. So how I showed you, right, sometime before. So from where we are learning that route. So we are learning from the static, right? We are learning from the static. See here. Yeah, here, guys. The outputs are very important. You need to understand. So if I type show IP route 192.168.1.10 IP address, so it is learning via static and the distance is what? 1, which means the AD value is 1. Now if you see, right, now if you see, the same thing is learning now show IP route. Yeah, the same command show IP route 192.168.1.10, which is learning via the RIP and the distance is what? 120, which means the AD value is 120. So that's how you need to troubleshoot, guys. So we are getting all the routes, end to end routes, so we don't have any connectivity issue. Now what I'll do, right, so I'll assign the IP addresses on this LAN machines, and we can wind up once we once we verify the communication. What we will do, right, so I'll assign the IP addresses on this particular machine. So we have taken long time to you, so we'll assign the IP addresses here and here in this machines. Then we'll verify the communication between end to end, end to end, which means so we'll try to ping from this machine to this machine. If it is reachable means fine, so both the network is having good communication. Even from the same machine we'll try to reach to this 3 dot network also. If it is reachable, then we will wind up the session, guys. So that's what the verification part now. So verification, routing verification we perform. Let me open this VPC. Okay, so I'll open the VPC. If I open, what is the IP address? Show IP. I'll quickly assign the IP address, guys. I'll quickly assign the IP address. So here we don't have IP address. To assign the IP address in the VPC, IP space 192.168.1.10 slash 24. Gateway is 192.168.1.1. So I hit enter here. So this is what the IP address, right? So let me check IP now. Show IP. So if you check show IP, okay, we have the IP address. If I want to ping 192.168.1.1, my gateway address, fine. Gateway is working fine. So likewise, I'll take this VPC from this PC from this here in the router 2's LAN network. Let me take this PC and I'll assign 2.10 IP address for this guy. Show IP. We don't have IP address. IP space 192.168.2.10 slash 24, and the gateway will be 192.168.2.1, right? So once I have assigned the IP address, we'll verify the IP. Show IP. So what was the IP? Fine. So let me try to ping the gateway 192.168.2.1, right? 2.1 is the gateway for this LAN mission. Fine, I'm able to reach. Fine. So I'll take this PC also. So we will assign 3.10 for this particular VPC. So again, this PC will also not have IP address. So I'm assigning the IP address. IP space 192.168.3.10, and the subnet is slash 24. Gateway will become 192.168.3.1. So once I hit enter, then I'll verify the IP address and we'll verify the show IP. Cool, we have the IP address. Let me try to ping 192.168.3.1, the gateway of the LAN user. See, every machine is trying to reach each other. So now we will verify. Now we will verify as we discuss, right? So as we discuss, we will verify first this connectivity from source IP, guys. From source IP 1.10, sorry, 1.10 to the destination IP. I'll try to reach first this machine. This machine IP address is 2.10 and this machine IP address is 3.10, right? So 1.10 to 2.10, and let's see whether the communication is happening or not. So I'm in VPC, this VPC. Where is that VPC? VPC 1, right? So this is my VPC. IP address is 1.10. Now I'll try to ping as we discussed a 2.10. Ping space 192.168.2.10. Let's see whether the communication will happen or not. See, we have the communication. Fine, we have the communication. So since from here I can reach 3.10 machine as well. I can reach 3.10 machine as well. So everything is end-to-end connectivity we have, guys. So this is how we used to do the labs, and you need to be verify the things. So any doubts or concerns still here, just let me know on the chat. So I'll be available for you to explain you guys. Okay. So hope the session was informative and you got some like practical things and the practical knowledge and the network use skills and tips as well. So let me know, guys, if you have any doubts. Okay, or else no doubts. Okay, thanks, Pallavi. So how was the session, guys? You guys are able to understand, right? So like, is there any issues? Just let me know, because I tried to explain you all the functionalities, how the RIP is going to be work, and advantages and the disadvantages, as well as like the configurational and the syntax wise, how what syntax we are going to be used. So how the syntax would be, and the labs we perform here. So yes, guys, now ball is in your court. So now you guys has to be let me know. So how you really so you do you have any issues? Okay, just stop the sharing if you have any issues. Okay, and let me know. So here I'm here, guys. And any explanation part? Yes, guys. Any issues? Any problem? All good, Kiran Das? No, sir. Okay. Yes, Pallavi. Pallavi, good. Other guys. Other guys, what you are doing, man? Other guys. Other guys. If you guys have any doubts or concerns, just ping me on the group chat. I'll let you know. Good. Okay. Um, Ishita, fine. Okay, no doubts. So, how many guys perform the static routing lab, guys? So, did you guys perform the static routing labs previously? We have a previous session, right? Did you guys covered that lab, and you have any doubts on the static routing kind of thing? So now let me know which is the better one. Like static routing is better or the dynamic routing is better, guys? Static routing protocol is better or the dynamic routing protocol is better? Which one you are going to be prefer in your organizations? So as of till now you learn this one, right? So how the things are working. Dynamic is better, Kiran. That's fine. Pallavi, fine. So it depends, guys. Okay. Again, I'm not telling you so only use dynamics. It depends on, okay, based on the scenarios and the situations. You guys has to be use the routing protocols based on your situation, right? So in generally in the production network, you will see the static routing as well as the dynamic routing also. So you will see the static routing and dynamic routing in the production network. So better you should have a good understanding on static and dynamic routing protocols. So since from tomorrow, guys, the tomorrow I'll as you know, right? So we have the different time slots. Okay, I'll let you know on that part. And tomorrow we will use our own personal teams meeting to discuss on the next topic and the next routing protocols. So hope it's clear for you all. Thanks for joining Network Ninja, the live session. Okay, if you have any doubts and if you want to heard something, like if you want to learn something from us on the any other topics, do let us know on the group chat. Okay, so while you are watching the video, if you have any doubts, do ping the messages as well. And and if you want to learn any other like the new technology or the new protocols, or if you have any doubts on the new things, do let us know on the group chat and the ping one as one on one. So we will respond you and we'll try to give you the solid and practical knowledge, okay, and the practical discussion. So we might discuss this routing protocol in 20-30 minutes. That's not an issue, but we should go deep dive. So as we mentioned in the as we mentioned in the statement, right? So master in the dynamic routing protocols and deep dive in the RIP. So that's why we try to give you the solid knowledge. So we show you like how to configure and the discussion points as well, right? And the troubleshooting as well. So we done the live troubleshooting. See, I told you, right, multiple times when you configure in the router in a routing two different routing protocols like static routing and RIP. So this is like the router is going to install the route whichever the AD value is having a less AD value. So that's what's happened in the router 3. So when we configured even RIP also, but we are not getting the route from the RIP, we are learning that same route from the static route because of AD value. That's again the proof point for you guys. Okay, I showed you that as well, and that is very important, guys. In interview, definitely you will see that cross question. In interview, definitely you will see that cross question. Okay. Okay, guys, then fine. Thanks for joining Network Ninja. So I'll wait for 2 more minutes. Okay, dynamic routing for large organization. Yes, Sai Kumar, dynamic routing for the large organization. See, static routes, we can run the network only with the static routes also. But for the small kind of organization, static route is fine. But in the enterprise network and the large networks and the medium scale of network, we definitely require a dynamic routing protocols for the as we discussed, right? So we discussed in the final in the previous sessions, like in the dynamic routing protocol we have a IGP and EGP. IGP like RIP, EHRP, OSPF, and ISIS. These routing protocols are going to be configured all small organizations static route. Yes, okay, these routing protocols we are going to be configured within a organization to allow the communication between a two different autonomous system. Then definitely we need to configure a EGP, right? EGP means a BGP, eBGP, border gateway routing protocol. That's again dynamic routing protocol, right? So better you should have a clarification on the differences between what is IGP routing protocols and the EGP routing protocols, how the things are working, how the troubleshooting part. Guys, be familiar with the technology because like see there are a lot of freshers. See, Still you will see in the industry, guys. I'll tell you the job wise in the industry, like the Jan, you will see the fresher guys. Like mostly already we have a fresher guys, 2026 pass out, like 2025 pass out and the 2026 pass out guys, right? So still we have a back end guys also. Like since from 3 years, 2 years, they didn't get the job and they're still trying to learn some new things and they're still surviving in the industry. So if you don't be perfect in your technology, see, every time industry is going to give the chance to the freshers because they can hire for the freshers in a less package. Okay, so as you spend successfully waste your time 2 years, 3 years, then again you are going to consider yourself as a fresher. It's a very really shameful thing. Okay, so I'm telling you, like in front, this is what the true, but no one is going to tell you. But I'm telling you, this is the true, guys. Okay, so interviewer is going to be consider you and the 2026 pass out guy both as a fresher, and they are going to give the more preference for the freshers only. Okay, if you go with this kind of stuff, this kind of knowledge with as a fresher tag to attend the interviews, definitely you will have a good opportunity. So always be focused and try to learn. Don't waste your solid time. People used to be waste the time like anything. They'll not consider that time is a valuable. Time is very valuable. See, even now you guys are freshers, right? If you waste successfully 1 year or 1.5 year, then again you will have a, like how in engineering we used to have a backlogs, right, for every semester. So the same thing, the same kind of thing in jobs portal also. So they are going to give you only freshers 25, 26 pass out, only freshers 26 pass out, like that. Okay, so you will at that time you will definitely feel, guys, so we face successfully without doing anything. So that, see, we have here a few guys. Okay, even though they experience a lot. Okay, I don't want to disclose their names. Now, by God grace, they got selected in a few organizations. They are working fine. Okay, they are doing good job. That's good for them and for us also. Okay, they are my student only. Let's see, in a 101 call, the next week we will have an interview session in 101, not in a YouTube. Okay, in a 101 call in a Teams meet. So I'll disclose the names and I'll share all the candidates profiles as well, and they are going to interview you first. Okay, so once you clear their interview, then I'll take the interview from my side. So let's see, the next week we will have a, hopefully by the next week we are going to cover by next week. Yeah, by, yeah, we have almost 9 days, right, to end of this month, right? So within this end of this month, we will try to cover all the routing protocols along with the configuration, verification, troubleshooting, and good solid knowledge. With a good solid knowledge, then I'll arrange an interview only for the routing things. Okay, so we'll ask the protocols, OSI model, TCP/IP, like the Ethernet headers and layer 2 header, layer 3 header, IP header, and the TCP/IP headers, and routing protocols and the configuration syntax and the verification part. So be ready for that, guys. Okay, and yeah, that's what from my side. And if you have anything, just do share on the group chat. Yes, guys. Do you have any other doubts, or are there any things, like anything you want to be shared? Uh, let us know. So if you know anything, right? So the other guys will also be get to know that what really you know about the industry and what really you know about the technology, how the industry is. So it's really helpful for other guys also. So Sai, Sai Kumar, if you have handy that questions, right, which you shared, so the last interview which you got attend and selected, could you please ping on the group chat so that it will be helpful for the other guys as well? Said Sadiq, how many times you will give interview? Yeah, see, guys, this Sadiq, right? So there is a Sadiq. That Syed Sadiq is my old student. First, he got the job in entity data. Now, recently, he is working. Currently, like he joined another organization, HCL. Okay. Still, since from 2 years, he's traveling along with me. So, Sadiq, please leave us, bro. Okay, give space for the new students also. I'm excited. Give interviews, sir. So you already excited. I know that you are a Mr. Pro. He has a good understanding on the routing protocols and the switching, as well as the Palo Alto firewall and the FortiGate firewall, and this one as well. Wireless technology also he knows that, and he know how to upgrade and password breaks. Like whatever the things he is working on the incidents, guys. Okay, incidents and the project management. Like, so whenever he get the new project, he used to work on the new implementation things. So he need to implement, right? So he should have a good understanding of the routing protocols and the switching protocols and the design wise. So that also he have. And even though he used to work on the incidents, like the troubleshooting things, the tickets, so he has that knowledge also. Even though he used to work on the ACI, guys, he is very one of my very good, yeah, lifetime subscription I got from you, bro. Yeah, you got lifetime subscription. Thank you. You can join at any time, buddy. And do share some knowledge or feedback to other students as well. So let them get something in the industry, like some good things, some good things. Okay, Sai, do you have any if you do, if you have a handy that questions, right? Do paste on the group chat, buddy. Okay, or else no problem. If you have, you can paste me, or else I'll give one to one on one with those guys. Okay, thanks everybody. Do you have any other questions, guys? Or else we can wind up. See, we take have taken like today 2:30, like 2.5 hours, right? So it's good for you and others also. Any other things, guys? Any other things? Any feedback, Sadiq sir, to the new students and the new Chinese who are really looking for to learn the new things, what they wants to do, what they want to be learn. Just give a single line feedback, what they wants to be learn. Yes, guys. No doubts, no doubts. Okay, sir. Come on. Okay, okay. Okay, fine. Kiran, are you there? I didn't saw your message, buddy. So, do you have any doubts? No. So, have you practiced the lab? Okay, all good. I'm happy if all good. Fine. If you happy, be happy, buddy. Don't worry. And all good. Okay, guys. Then we can wind up the session. I don't think so that you guys are having any doubts. Okay. Mm, yeah. Just wait 1 second. Okay, keep learning. Yes, Syed Sadiq has said something. Okay, keep learning new things and all the best for your future to all. Okay, thanks, buddy. Thanks, everyone. Okay, thanks everyone to join the Network Ninja. So we'll touch. We'll come up with a new session with the next week or whenever we get time. Okay, if you want to learn something new from us, and do let us know. Okay, we'll take the session on that topic. Okay, thanks everyone. Okay, Sai Kumar. Guys, one thing, guys. Before you guys drop, okay, I want you guys to be here. So Sai Kumar recently, like just now, he posted one message. Do copy that questions, all the questions. Yesterday he has attended the interview. Like since from 1 week he is trying to be attend and everything is good and he cleared that. Okay, do copy that questions and keep yourself for the reference. Okay, for the freshers, this is how they are going to ask the question. So they ask to Sai about OSI model and the difference between TCP and UDP. How you will solve your how you will solve if the user is not getting the internet and things, right? And other things, what is switch and what is router, how the switch is going to be work and how the router is going to be work. Do copy those questions, because if I end the live, right, that chat is not going to be populate on the things. So better, guys, do copy that, and once you copy, let us know. I'll end the session, I'll end the live, so that you can have a session and learn the new things. Limited, so I'm unable to share all the questions. Okay, Okay, fine, Sai. I'll share that. I have already have it. You shared with me, right? So I'll share one to all the guys. Thanks, guys. Then thanks for joining Network Ninja. Bye bye. Take care. Have a good day. Do revise this video so that you will get to know what exactly we done today's session. Thanks, everyone. Okay, have a nice day.